All right, number 10 says, is that working? Is that on?
Yeah.
Is that on, Isis? Yes? Okay. Number 10 says, from a height of 2.5 meters above the floor of the basketball court, forward, it's one of the positions. There's 5 positions on a basketball team, 2 forwards, 2 guards, and a center. So the forward's name is Paul. He's shooting. Paul Pierce tosses a shot straight up next to the basketball hoop with a kinetic energy of 5.4 joules. If his regulation size basketball has a mass of 0.6, that's the basketball, 0.6 kilograms, okay? Will his shot go as high as the 3.04 meter hoop? So, and that makes sense because usually the basketball players, I am 195 centimeters. So he's easily at least 2 meters and he's jumping. So 2.15 sounds certainly correct, at least. And the basketball hoop is 3.04 meters. He has 5.4 joules of energy, correct? So if the ball starts at this height, does it have enough energy to make it to that height? Clear? Yes? So if I throw the ball, here's the ball, okay? Here's the basketball court, okay? And here is 2.15 meters, correct? And that's where he's releasing it from with kinetic energy. Correct? Does the ball have enough energy to make it to 3.04 meters? Okay? So what's the difference here? What is 3.04 minus 2.15? What's that delta H?
0.89.
What is it?
0.89.
0.89 meters. Okay? So how would you do this? How would you do this? In other words, when it reaches this height, make a statement to me about the increase in potential energy. Isn't it going to be the same as the change in kinetic energy? In other words, they're asking, is the change in kinetic energy equal to the change in potential energy? So that's what they want you to determine. They want to know, so you're going to spend 5.4 joules of energy to get there. Does it have enough? So you would say, I'll just write over here. This is the next problem, but I'll just write here. So, in other words, the change in potential energy, it's going to increase by 5.4 joules, correct? That's going to be equal to mass. Are we given a mass? Are we given a mass? Yes. The mass is 0.6 kilograms. G, which is 10, correct? And the height, which is 0.89. Yes? So you would say 0.6 kilograms times 10, and we know that that's meters per second squared, times 0.89. What is 0.6 times 0.89 times 10?
5.34.
What is it? What is it?
5.34.
5.34? So do I have enough juice? Do I have enough energy to get it up to the basket? Yes, I do. So the answer is yes. Okay, that's A-10, done. In the can. Okay. This one. This one talks about a screwdriver. So let me read the problem to you. Number 11. Mr. McIntosh, a computer technician, uses a screwdriver with a handle of radius 1.2 centimeters to remove a screw in the back of a computer. The screw moves out from the back. It moves out, so you're twisting it, it's going to come out. Moves out 0.2 centimeters. Do you understand what that means? It moves out 0.2 centimeters? Do you understand what that means? So you turn it once, and it's coming out 0.2 centimeters on one complete turn of the screwdriver or of the screw. Okay? What is the ideal mechanical advantage? And that's number 10. So what do we got?
Number 11.
What is it?
It's number 11.
It's number 11. Better. Okay, so what's the DI? How do I calculate the DI? We know that ideal mechanical advantage. Can you see if our friend is online, please? Ideal mechanical advantage is DI over DO. Correct? Now, as I take the screwdriver, right, and I make one complete turn, isn't that the circumference? One complete turn, right? Here it starts here. I'm going to go to there. That's one complete turn. So what's that distance? So that distance is going to be 2 pi times the radius, which is 1.2, right? And then the DO is the amount the screw comes out. So this is the machine. That's the machine working. This is the screw coming out. It's going to come out 0.2. This is centimeter. This is centimeter. Correct? So what is, can you do this for me? What is 2 pi 1.2 divided by 0.2? What does that equal? And this is A11. What is it? 31? What is it? 38, right? Okay, so it's 38. So the IMA is 38. No units. Now, that's why a thick screwdriver will work better than a thin screwdriver. You get that? Did you ever wonder why the handles are bigger? So here I have 2 screwdrivers. Just so happens I have 2 screwdrivers. So, Ramada, if you're unscrewing something and you want to use less force of these 2 screwdrivers, which one has the thicker handle? Black or red? Black, yes. This one has a thicker handle. You see? You get it? It's thicker. So it's the thickness of the handle. Yes, do you get it? So the thicker the handle, the better. Okay? Now number 12. All right, number 12 says, any questions on that? You okay? Number 12 says, Tom's favorite pastime is fishing. I'm going to do a lot of fishing when I go back to the United States. I have a friend of mine, and we're going to a lot of surf fishing. You know what surf fishing is? Fishing from the beach. Can't wait. All right, Tom's favorite pastime is fishing. How much work is required for Tom to reel in a 10-kilogram bluefish from the water surface to the deck of the fishing boat, 2.5 meters above the water, if the reel of his fishing pole is 85% efficient? Okay? So how much work is required for Tom to reel in a 10-kilogram bluefish from the water's surface to the deck of the fishing boat, 5.2 meters above the water, if the reel of his fishing pole is 85% efficient? Anybody? Can you do it? Can you do it? Can you do it? What's the mass of the bluefish? I didn't write it down. What's the mass of the bluefish? Mass
10 kilos.
of fish. 10 kilograms, right, Isis?
Yes.
Okay, good. Right? Now, so what do you do? What equation, basically, are you going to use? What equation are you going to use? Aren't you going to use this one? So you have F in, D in. Now, this is ideally, I know we're going to work with the efficiency, and then you're going to say F out, D out, right? So what are we solving for? What are we solving for?
Work.
What is it? What are we solving for?
Work done.
Work done? Is that what it says? I thought it said, did it say work done? I apologize. It says, Tom's favorite pastime is fishing. How much work, okay, good. How much work is required for Tom to reel in a 10-kilogram bluefish from the water surface to the deck of the boat, 5.2 meters above the water? So, if you're talking about ideal conditions, where the machine end and the person end, in other words, the ideal, which is here, is the ideal, and then this is the machine, this is the real, right? So how much work are you going to do? Do you know? Isn't this product? Can you find that product? Can you find that product? Can you find one of these? Can you? What's the weight of the fish? What's the weight of the fish? What is it? 10 kilograms, right? And how high off the boat is it going to go? How high off the water?
5.7 meters.
Okay, so, but isn't that work? Isn't that potential energy? Isn't it? So, aren't you going to use a change in potential energy to help you here? That's where I'm going. Right? So what's MGH? It's going to be MGH delta PE is going to equal, we did this one, right? I can erase this? Right, I just want to use the room here. So this is going to be delta PE, equals MGH, and that's going to be equal to what? What is the mass? The mass of the fish is what? 10 kilograms, right? Right? And then it's going to be 10 meters per second squared, right? And then what? What's the height? Yeah, the height from the water to the deck of the boat is 5.2 meters. So what's that value equal? What's that value equal? What is 10 times 10 times 5.2? 520 joules, right? Correct? Is that right? 520 joules? Yes? But, is that the answer and why? Is that the answer and why? No, because he's using a reel that's 85% efficient. It's not 100% efficient. If he was using a reel that was 100% efficient, that would be the answer. But he's got to use more energy, doesn't he? Yes or no? So what would the answer be? This represents 85% of the answer, doesn't it? Yes? So in other words, 0.85 times the answer is going to be 520, is that right? So what's the answer?
612.
What is it?
612.
612, that's right. 612 is the answer. So the work it's going to take to get that fish on deck is going to be 612. Do you get it or no? Ramada, do you get it? We did this, and that's ideal conditions. We said, look, the deck is 5.2 meters above the water. The mass of the fish is going to be 10 kilograms. 10 times 10 times 5.2. So the change in potential energy, equals 520, right? But he's using a reel that's only 85% efficient, correct? Yes? So 85% of the amount of energy that he actually used is going to be what? It's going to be the amount here, correct? And that's going to be 612. Let me put it another way. Let me erase this, okay? Relative to work, what is the equation for efficiency? Relative to work. What is the equation for efficiency? It's right on your paper. Relative to work, what is the equation for efficiency? Ma'am? Is it there? That's power. It's right here. One more. There it is. Relative to work, what is the equation for efficiency? Right? Isn't it work output? Work output over work input? Isn't that efficiency, correct? Isn't it? Yes? That's the ideal value. That's the minimum value, correct? Yes or no? So isn't that this work here? Isn't that the output work? Based on the change in potential energy that, without using a machine, right? That the fish goes through. The fish goes from the surface of the water to the deck, and that's going to be a change in potential energy, which is the work output, right? So that's going to be what? It's going to be what? 520 joules over work input is really what we're asking, equals 0.85. So solve for Wi. It's going to be 520 divided by 0.85 equals the work input, correct? So I can erase this here. And I can say 520 joules over 0.85 equals work input. Same thing I did here, correct? Yes? This is a little more conceptual. You're trying to figure it out mathematically using some logic, correct? That's the equation I just plugged in. Yes or no? You get it? So that is numbers 10. Oh no, we didn't finish, did we? Is there more to do with number 12? All right, let's clean this off. So what did I do? I got work input equals 612, right? Work output equals what? 520? All right, what else? What else do they ask you? This is number A-12, right? Did we lose Elvis? Is he okay? Okay, excellent. So B, it says if Tom applies a force of 15 newtons to the reel's crank handle, what is the actual mechanical advantage of the fishing pole? What's the actual mechanical advantage of the fishing pole? So Fi is going to equal 15 newtons. I have that up there, right? I did have it, didn't I? Okay. Anyway, I have it here. And so what would it be? The actual mechanical advantage would be what? I didn't have it. Let's go back here. Let's go back here. And what I did have was, I had this. The mass of the fish is 10 kilograms. So what would the FO be? If the mass of the fish is 10 kilograms, what's the FO? In other words, what's the weight of it? FO equals FW. 100, right? 100 newtons, correct? Yes? So FO is 100 newtons. So AMA is going to be FO over FI. So what's going to be AMA equals 100 over 15. What's 100 divided by 15? All right? It is 6.7. So AMA equals 6.7. Okay? The AMA equals 6.7. And C says, what is the ideal mechanical advantage? What is the ideal mechanical advantage? Well, we can do this. We can do this. All right? I'll do it here. I'll erase this. What is efficiency in terms of mechanical advantage? Efficiency, EFF equals, is it IMA over AMA or AMA over IMA? It's AMA over IMA. Which is, what's the AMA? 6.7. We don't know the IMA, but we know that that's going to equal 0.85. Correct? Solving for IMA, it's 6.7 divided by 0.85. Right? Can you do that? Can you solve that? So we have an answer here, and 7.9, is that okay? 7.9 is correct. So the IMA equals 7.9. Okay? Yes? Are we finished? Okay. 3 problems left. Excellent. Okay.